So hello everyone. This is the application that we have created for our information retrieval project. So what we first need to do is upload our image. So to upload that, we click on upload and upload an image. So once we upload our image, our system goes through our classifier and classifies image as either edible or poisonous. So once we have classified that, we provide a little bit of information regarding what we mean by edible or poisonous because it is open to interpretation. So there are different definitions for edible and poisonous. So we want to be clear about what we mean. So once we do that, what the system is doing right now is taking that user image and finding its feature vector and storing it in our database. Then from database, we retrieve this user vector and the user vector of images that were already stored, and we were building our annoy index. So once we build our index, we find similarity and we store our images in our Google Drive. So as you can see, it's done. And we have also currently classified the plant species as chicory. So when we click to find similarity, we are able to retrieve all the images that were stored in our image database that were most similar to chicory. So as you can see, the system seems to do a pretty good job. And we have also ranked them in the basis of their similarity. So the higher ranked images are more similar images. So now you must have seen click here for image information. So when we click on that, we get additional information about our image. So basically what we get is first our image histogram. Image histogram are quite useful when we want to find if a certain process has been applied on our image or not, or if you want to find a certain filter needs to be applied on our image. So they are quite useful during the reprocessing step. Now we have image edges. So basically we have done edge detection using 4 different algorithms, Sobel, Roberts, Scar, and Pivot. And the main purpose of using 4 different algorithms was we wanted to see which algorithms perform for our image because an algorithm might perform differently for different images. So it's case to case basis. As you might notice that Pivot or Scar seems to perform better than Roberts in this particular case. And the main purpose I'm doing or maybe even detecting edges is because it gives us a fair idea about what sort of features will be detected in our image. So if there is some noisy points in our data, or if there are certain features you don't want your model to detect, like for example this part, so you can remove that during the pre-processing step to improve your model accuracy. And again, we have grayscale, blurred, and sharpened image. So basically, you have to convert your image to grayscale every time you enter a new image because a normal image has 3 values, pixel values, RGB, and that is quite computationally heavy on models. So we basically convert it to a grayscale value, and so that we only have one. And how we convert it to grayscale is basically we average the pixel values, RGB values of each pixel, so that we only have one component that is gray. So it is easy on our model. Then we have blurred image. Blurred image are quite useful when you have a noisy image. Basically, if you have a raw image, then there is usually a lot of noise. So image blurring helps remove some of those noises. And then you have sharpened image. Sharpened image in this example is not that great, but usually what sharpened image are used for if you have a sort of a blurry image. So you can sharpen it and highlight some of its edges even more. And usually how we do it is basically we subtract a blurred image from the grayscale image and we get a sharpened image. That's one way of actually sharpening your image. Then we have feature maps of our output layers. So feature maps directly are not that useful, but suppose we store feature maps of all different types of plants or for any class, and we compare them. So it is possible that a certain class, certain feature is only getting detected for certain class. So we tried doing that for poisonous and edible plants as well, that if a certain plant, if a certain feature is only getting detected in poisonous or edible, but we were not able to find any useful results at the moment. So to again return back, all we need to do is click on return. And again, suppose we want to test for a poisonous image, so we just have to upload, and it has again classified it as poisonous, give a little information about what we mean by poisonous. And again, we are repeating the same process of building, and it takes a little bit of time because 90% of our data is and more code is stored on client side, and only a little bit of data is stored on server side, so it usually takes a little bit of time. So it has again correctly classified the species as lily of the valley, and once it's done. Like now we can click on similarity and again get similar images. Yeah, so this is how we do, and we can repeat the process as many times as we want, and again if we click on it we'll get image information. Thank you.